Welcome all. My name is Sheikh Ahmed, and the reason of creating this video is to translate and explain the content of Campus X YouTube channel, but in English, which is obviously run by Nitish sir, because what I think the explanation and content and insights that Nitish sir provides on AI or any other concept are unmatched, and no one else offers the depth and clarity that he brings to every topic. But the amount of consumers of that content are so less. And also for those who can't able to understand in Hindi, I think it would be very helpful. And also those who wanna prepare for interviews, as at the end we have to give the interviews in English. I really think that the knowledge which is shared by Nitish sir is so valuable, and very few amount of Hindi known folks are getting advantage of it, and the rest of them are not. So I had decided to create more content and present it in a more enhanced way. First on this Transformers playlist. After that, I will continue deep learning playlist, which is covered by Nitish sir in 100 days of deep learning, because I have seen the demand of this topic in the comments. But this will totally depends on the positive feedback from you and the approval from Nitish sir. So if I got the approval from Nitish sir, I will definitely continue this lecture series, translation series, whatever you can call it. Okay. So check out my work and let me know what do you think about it. And stay tuned for the update. From today's video, we will start studying transformers. This is going to be the first video on transformers, and I plan to give a detailed introduction about transformers through this video. And we will discuss what are transformers, what has been their impact on technology, and also we will discuss the architectural overview, and we will also discuss the factors that led to the creation of transformers. So okay, and also we will discuss the advantages and disadvantages of transformers, and finally what is the future like. So through this single video I will try to give you uh, a great overview about transformers, which will help you a lot in the upcoming videos when we will try to understand transformers by going into great detail. So I hope you're excited for the next 4 to 5 videos. So let's start. So first of all, let me tell you in very simple words what transformers are. Okay, so transformers is basically the neural network architecture that you have studied in this course so far. Okay, so let me tell you in very simple words what transformers are. So transformers is basically the neural network architecture that you have studied in this course so far. Then you have studied ANN and you have studied CNN. Have studied ANN and you have also studied CNN and also the RNN. Right? What are these three? All three are neural network architectures in very simple words, which are made for different types of data. For example, if you talk about ANN, it works very well on table data. If you talk about CNN, it works on image based data. And if you talk about RNN, it works on sequence data, such as text data. In the same way, transformers is also a neural network architecture which is made to handle sequence to sequence tasks. Okay, which is made to handle sequence to sequence tasks, where you get sequence data in input and your output is also in sequence data. A very famous example of such task is is machine translation, because I don't have that pen and tablet kind of stuff, so I have pre-written this all things. So maybe in future if I have those things, I will try to write and explain at the same time. But likely to sell, but right now I don't have those stuff. So manage. So what I'm saying, a very famous example of such task is machine translation. Basically, the task of translation is where you convert a sentence from one language to another language. Or another example is a question answering system. The second example which I have mentioned, uh, question answering system. Or another example is a text summarization system where you generate a summary for a large text. So you summarize the whole text in a few amounts of words. So transformers were developed specifically to handle these kind of sequence to sequence tasks. That's why they are called transformers, because they transform one sequence into another sequence. Now, if you want to see how transformers look, then this image, let this image is uh, actually the architecture of a transformer. You will find this image in the original paper of transformers. This is actually architectural overview which I have mentioned here. So now seeing it directly, it first seems a little bit scary because there are too many components. But if I give you a high level overview, just like other seek to seek model architectures, here also you have an encoder, like you can see here. This is one. This one is encoder part. This one is decoder part. So this part is encoder and that part is a decoder. What is different here is that you do not use LSTM. Here you must have seen in the previous sequence to sequence architectures. Here you use a form of attention which is called self-attention, due to which the encoder here can process all the words of your sentence simultaneously. Like it can it can do parallel processing, due to which this architecture is very scalable. That means it can handle very big data as well. It can also be trained on very big data. Apart from this, complex architecture is made by combining many other small and big things, which we will read in details later. But for now, you can just summarize it to transformers. Okay. Transformers is basically a neural network architecture which was created to handle sequence to sequence tasks. And just like previous seek to seek architecture, here also there is an encoder and decoder. But here you do not use LSTM, which was used in the previous architecture. Here instead you use a form of attention is called self-attention. Okay, because of which what you are able to do is that you can send all the words of your sentence simultaneously as input to the encoder. Basically, you are able to do a parallel processing, and because of that parallel processing, your training of transformers architecture become very fast and scalable, due to which you can train this architecture on very large data set as well. Okay, I hope you got a basic overview. Now, before moving ahead, let's take a little historical perspective, because it will help you so transformers to understand the transformers from the scratch. So the architecture was introduced in 2017. In this groundbreaking research paper, attention is all you need. This paper came from Google Brain, and this is the first paper where the transformer architecture was introduced. The concept of self-attention was introduced. So trust me, after the arrival of this paper, there was a revolution in the space of deep learning. Everyone's attention fell on this paper, and in the last 6 to 7 years, I don't know in how many places has the transformer architecture been used, and now it becomes so popular that most people know about it. If someone is studying data science, AI, machine learning, they know what transformers are. So popular today. Uh, and a great example is ChatGPT, which is the most popular software in the world, according to me. That essential is daily essential is transformers. I don't know how many startups have come up by making transformers based technology, which which have raised funds in billions. A lot of jobs have been created. In short, an AI revolution has come, which we have been able to feel for the last 1 or 2 years. Okay, and people like me and you, we are still trying to figure out in this AI based new world what we are doing in the future, what we are going to do in the future. It is very easy to start a technical discussion, but on transformers, and we will uh, do that too, but that I want to give you a little motivation, and I want to explain transformers. Although only a small architecture, which is visible, which is, I mean, it's a very small architecture, right? But uh, it's basically this impact. But the impact of this transformers is very profound. It's actually a fun thing to know. I mean, actually, when these researchers wrote this paper and published it, they made transformers only to to solve the task of machine translation and to achieve state of the art results. uh, they also did not know that transformers will become such a big thing in the text in the next 7 8 years, right? So the they don't think that it will revolutionize the entire space of deep learning. So my goal is that I want to explain you a little about the impact of transformers on the world, on society, on technology, because it will give you a motivation to learn transformers well. Okay, so let's discuss profound impact transformer on tech and society. Let's discuss the impact of transformers from a technical standpoint. And the first point I would like to discuss is how transformers has revolutionized the field of NLP, the field of NLP. The field of NLP was the field where Transformers was born. That is, Transformers was created at least initially, and the biggest impact of Transformers has been in the field of NLP to solve NLP problems. If you talk about NLP, natural language processing, then it is something which has always been very important for the field of AI, because natural language is how to talk to other human beings, and we have always been trying that if only it could happen that the way we talk to any other human being, in the same way we can or we could uh, talk to machine or computer. And trust me, work has been going on in this field for the last 50 years. First heuristic method were developed, uh, then your statistical ML based models were tried. Like you must have read about the naive Bayes algorithm and hidden Markov model and SVM support vector machine. And if you talk about heuristic bag of words and grams, okay, all of these methods were tried. Then a lot of work was done in early deep learning as well. The concept of embedding came here. Okay, here you can see have mentioned the points which I'm talking about. So the concept of embedding came here. Then LSTM, RNNs, all these were also used a lot to solve NLP problems. Uh, but since the transformers came, you can leave any NLP problem on the transformer, and the transformer is giving you state of the art results on on that problem, right? And the benefit of that is the biggest problem of NLP are now getting solved. That means ChatGPT is a great example. At least today in my life, I have started using instead of I have started using Google search engine less, and I talk more on ChatGPT on a daily basis to solve my daily queries. If you buy a product from a company and you have a problem, then if you go to that company's website to resolve that, you may have seen that there is a chatbot uh, inbuilt on on that website. You go to that company's website to resolve it, so then you may not be able to tell whether you're talking to an actual agent of that company or a chatbot. Many companies have released services like boyfriend and girlfriend. So in short, the progress that was going to take 50 years in the field of NLP, that has happened in the last 5 to 6 years, all because of transformers. Another very big impact of transformers has been that they have democratized AI in a way. What I means is that earlier, if you had to make an NLP application in earlier, then you used to build the model from scratch using LSTM in deep learning, etc. Now, obviously, if you are building a model from scratch, then you will need a lot of data. And then on top of that, you will have to work very hard to take that models to such a stage where your results are coming good. But mostly in the first fall, to do this whole thing, you need a lot of hard work, a lot of data, a lot of money, and after that your results are also not that good. But after the arrival of transformers, these things changed completely. Transformers, as I told you a while ago, is a very scalable architecture, which means that they can be trained on very efficient, very large data set, and this was done. Transformers was actually trained on very large data sets, which gave us such architectures that you can use for your small tasks. I'm talking about transformers like BERT and GPT, which were first trained on very large, huge data sets, and they were left in the public domain. So anyone can download and use them. Now, what is special about these transformers is that they are trained on very large data sets. But if you want, you can fine tune them on your small specific data. So the knowledge they have of big data sets can be transferred into this specific small data sets as well. Okay. Basically, the concept of transformers learning, which we studied in the domain of computer vision, you have brought it to the domain of NLP. So now, what is the benefit of transfer learning? Transfer learning, that if there is a small company, startup, or an individual researcher, if he is making an NLP application, then what he can do very easily, that he can pick up these trained transformers and apply them on his task and achieve state-of-the-art results, which was almost impossible earlier. So today, because of transformers, AI became democratized. The best part is that this small code where I have to do fine tuning, I do not need to write that from scratch. There is a library like Hugging Face, which is assisting me in this work. In just 3 to 4 lines of code, I can actually create a state of the art sentiment analysis NLP app, just like that. Let's talk about third point, and impact transformers according to being multi-model capability and transformers. The third point which I want to see before that. So, so one of the many good things about transformers is that architecture of transformers is very flexible. So, for we have only um, see how you can use transformers with text-based data. But if you want, you can also experiment with different models. which means that transformers does not work only with text data. If you want, you can give different types of data transformers, like you can also work with images. You can also work with speech, and you can experiment with different models, which basically means that you can create such a software using transformers where you can where you give an image as input, and it generates another image or some text as input. And this is possible because the architecture of the transformer is which is very flexible. So what happened in the last 6 7 years is that everyone noticed that transformers are anyway so great and universally applicable, that made that many researchers started doing research in this distance, sorry, in this direction, uh, that how can we put different modalities, input and outputs in the transformers, and what did they do in this process. Okay, so they created different types of representation. So when you input text into a transformer, what do? You convert the text into an essential representation and put it in the transformer of or take it out, uh, apply the power of the essential transformer on images and speech as well, obviously. And this is what happened in the last 6 7 years. Researchers and researchers are and being able to create representations that were similar to text, and you can apply them exactly the way text is applied on the transformer. So what has happened today is that you have such applications which multi-model, like ChatGPT. Take the example of that. ChatGPT is such a tool where you can do visual search if you want. I can upload an image and ask questions about about it, or I can talk to the ChatGPT by giving audio input because of multi-modal capability. If you want, you can create a tool to which you can pass a text description, and you can pass a prompt, and it will give you an image output like daily, works, or a mid journey works. If you want, you can create tool where you just give a text input and it will create a complete video for you, like it works in runway ml, or in a lot of such apps and startups in the world, which is essential transformers, but they are experimenting on different modalities. So this is the best part about transformer, that is democratized the whole thing. As we discussed earlier, the different modalities also. So I will call the fourth point, impact transformers, is acceleration of acceleration of generative generative AI. So that means a generative AI is a field of AI where you make machine learning models whose job is to generate something, like generate text or generate images or generate videos, anything. So work is ongoing in this space the last 10 years, but that work was very slow. Many models had come out, like GANs, generative um, adversarial networks, with the help of which images, etc., were generated. But many of these things we are not in industry grade. They could not be converted into products. But since the transformers came, they have completely revolutionized the task of text generation. Software like ChatGPT came, where it had the capability to generate human-like text. Due to which, what happened now is that many companies started making chatbots, etc., using open APIs. So, in short, generative AI in the field of text progressed uh, very fast in the last 1.5 year. After that, since transformers are multi-models, so then the same thing started appearing. What happened with the with the advantage of software like Midjourney, DALI in the image domain, that now people are able to generate images by inputting text. The input of the same video text, you can actually generate the video. Now the big big giants, like I recently heard that Adobe, which is Adobe's Photoshop, now has generate capabilities at the time of editing. You can actually generate a new portion inside the image. Similarly to that, the new Pixel phones, Google Pixel phones that are coming from Google, have the ability to edit any image. Like if your face get rotated little while taking a photo, then you can actually hold it and straighten so that the photo looks correct. All these technologies are now being explored very rapidly because of transformers have become very important. It has become a very important field, and today if you are going to apply for a data science position or a job, then there is a good chance that you will be expected to have some idea about the tools and techniques of transformers. So this is, in my opinion, the fourth biggest impact point of transformers, and the last impact of transformers would be unification of deep learning. We are going to discuss on this topic now. Unification of unification of deep learning. So far in the history of deep learning, it has been that you try to solve the problem by creating architectures for different types of problems. For example, ANN works best for tabular data, CNN for image-based data, and RNN for sequence data, and so on, to generate like GANs, etc. Recently, in the last 1 or 2 years, there has been a paradigm shift, after which it is being noticed that people are now using transformers for different problem spaces of deep learning. So if you are talking about NLP based sequence to sequence problem, then transformers are being used here. Now if you are talking about generators, so they are also, you are using transformers. If you talk about computer vision, then transformers are being used here too. If you talk about reinforcement learning, transformers are being used there too. If you talk about different science fields like science research, then transformers are being used in that space too. So this is the point in the history where unification of deep learning is being seen. Rather going for different architectures, now there will be a single architecture to solve different types of problems, and that will be transformers now. Now transformers itself has many shortcomings. There is a drawback and good chance that tomorrow a model that surpass transformers may also come. But this unification that is happening in a very important part, and according to me, it is a very important impact of transformers. So you should have an idea of much impact of transformers, and now I think it is a good time that we make our decisions a little more technical. So now I want to discuss with you origin story of transformers. Okay, let me show you uh, origin, let me show the origin story of transformers, and let's go a little technical, right? Okay. Like how the transformers from inside works, all the development of transformers happen, like how that, or the factors that created the requirement that there should be an architecture like transformers. We are going to read that now, and this whole origin story is actually made up of three research papers. So I will give you a little introduction about all the three research papers and try to create a narrative around it so that you understand this whole origin story properly. So first of all, around 2014 to 15, a very impactful paper came on sequence to sequence learning with neural networks. We will discuss this paper in great detail. 2 to 3 videos ago, we have discussed. But still, just for the story, let me revise you once. So in this paper, an architecture was proposed to solve sequence to sequence tasks like machine translation. It was said that if you have to solve a sequence to sequence task like machine translation, you can use encoder decoder architecture. And LSTM was used in both the encoder and decoder. Just to give you a rough overview, what do is that as soon as we are given a sentence like my name is Sheikh Ahmed, we enter this sentence as in the in this LSTM in this LSTM uh, in a step-by-step fashion. Now, what is the work of this LSTM? That it process these words and goes forward while maintaining a hidden state, and as soon as it processes the entire sentence, it gives us a context vector. You can consider this context vector as a summary in which the summary of this entire sentence is hidden. Summary of uh, this entire sentence is hidden. Like this context vector representation of this entire sentence, now we pass this context vector to the decoder, and then what does that decoder do in a step-by-step fashion? It produces output on a word by word basis, like this. You can see that what will produce. It will produce here. I have not mentioned the words of Hindi. Uh, I apologize for that. Just imagine that there here is the words in English, and it translates the single words in Hindi. So it produces output on a word by word basis like this. Okay. Now this architecture works fine if you have small input sentences, but as soon as your sentences become very large, as you can see, there is just a four sentences, words for four words. But as soon as your words become large, then this architecture starts failing, and the quality of your translation is not that good. Now, on understanding the reason behind this, I understood that the biggest flaw in the architecture is that we try to summarize this entire sentence inside this. Okay, inside this context vector. So this context vector is basically set of numbers. So we are trying to summarize this entire input sentence in some numbers. Now, if this sentence becomes very long, then it is obvious that your context vector will not be able to represent everything. It will not be able to retain everything, and hence the quality of the translation will not be that good. So this is the story of the first paper, where we proposed a solution to solve sequence to sequence task, and then we realized that that sequences, that if the input uh, consequences, if the input becomes very large, then our context vector will not be able to retain that much context from this model. Okay, to solve this problem, now the actual thing comes into the story. Now another research papers come whose name was neural machine translation. Let me show you. Neural machine translation. And here we got the solution. So by jointly learning to align and translate. So in this paper, which is written by this guy Bahadno, and this was written the first paper where the concept of attention was proposed to solve the above problem, which I have mentioned earlier. Which So the concept of attention was introduced to solve the problem. Now, let me give you a quick overview of how attention works. What happens in attention-based encoder decoder is that your encoder works exactly like it used to work in the previous architecture. Or so basically, here you send like see the architecture and the mechanism of working through working flow. Uh, what happens in the attention-based encoder decoder is that your encoder works exactly like it used to work in the previous architecture. So basically, here you send your input sentence in a step-by-step fashion, and the encoder works by maintaining a hidden state in every step. So here is your H1, here is your H2, here is your H3, and here is your H3, here is H4. Main difference that comes in the way, so the decoder works, how the decoder works. That's where the main difference comes. So the main ideological difference here is that the attention mechanism says that you do not need to send the context vector from from here to here at once, because uh, whenever you do translation, suppose you have to print this first word light, okay, this first word light means it means suppose this is your input sentence, turn off the light. So when you translate it in Hindi, the first Hindi word that will come is light. So the concept of attention says that to print this first word, you do not need the context of this entire sentence. Okay, you do not need the context of this entire sentence. You just need the context of some single word. Like to print light, you don't need turn off the this turn off the light. Okay? You don't need those sentences but about this light. Okay, also it doesn't mean the but you only means turn and off. So what do we do here? Instead of sending the entire context vector at once, we send a separate context vector at each time step of decoder, and this context vector is dynamically calculated, and this context vector tells us that whatever is printed at the current time step of the decoder, which is influenced by which time step of the decoder. Okay, for example, if I want to print a light, then the weightage of H4 in the context vector will be for the I want to the light context of this weightage. Yeah, here you can see this weightage is more uh, and H3 will be less, H2 will also be less, H1 will also be less. But uh, if I want to print in C2, then the component of H1 in is will be more. H2 will also be more. C2 from C2 one is also more, and H2 more, and H2 is also okay. Then the component of H1 in will this will be more, H2 will also be, H3 will be less, and H4 will be less. So basically my context vector is a weighted sum. It is the hidden state of my encoder, and these weights are what we call attention weights. Okay, this is the main difference which is introduced by paper, and this concept is called attention mechanism. Okay, so as soon as the attention mechanism was introduced in the encoder decoder architecture, the quality of translation improved, especially for sentences which were greater than 30 words. While the previous architecture used to fail on long words, the translation quality also uh, of this new attention mechanism based encoder decoder architecture was very good. But even after the introduction of the attention mechanism, there was still a big problem in this architecture, and that big problem was sequential training. This architecture is LSTM based, which means that here in the encoder you can send only one word input at a time. Then some processing will happen on it, and then you will send the second word. Then you will send the third word, and so basically you have to send your input in a sequence manner, which means that the training that is happening here is an inheritance sequence. Okay, so it is slow. It will become slow due to that inheritance quality of that architecture. You cannot train a very large data sets on the architecture. Now you will ask, what is the problem if I cannot train on a very large data set? The problem is that we will never be able to use techniques like transfer learning here. What happens in the transfer learning, if you remember the computer vision things that we have studied in in a little bit earlier in this course, what you do in transfer learning is that you train a CNN architecture on a very large data set, image sets, and this CNN architecture learns many things from these image sets. After it after it is trained on uh, trained, and then what you can do is you can fine tune this architecture on your task. So here it has learned many things, and what you can do is you can take this CNN and uh, make a dog versus cat classification by just showing 100 photos of cats and dog. But this thing is not possible in our case, because we cannot train this model on very big data, right? In the first place, we cannot train our model on big data. So when we are not able to do this pre-training, then the questions of fine-tuning does not arise. This means whatever you want to solve any task, and whenever you want to solve using this architecture, so you have to train the model from scratch, and there are two very big problems in training the model from scratch. First time First is time, and second is effort and data sets. You also need a lot of data. And the general meaning of data sets is money, because in collecting data and labeling it, you need money. So, in short, if I summarize, although the attention mechanism improved our translation quality on long sentences, it could not solve a very big fundamental flow, and that was sequential training. This is why sequential training happens, because inherently our encoder and decoder have LSTM, which accepts data in a sequential manner, which means we cannot paralyze it. And if we cannot paralyze it, it means that our training will be slow. If the training is slow, then by definition, we cannot train our model on huge data sets like TBs of data. If you do not train at this level, then the concept of transfer learning will never work. And the absence of transfer learning means that for every new project, you will have to train the model from scratch. So, which required a lot of time, data, money, which was never allowing this field to grow. So, this is the main problem which was responsible behind the creation of transformers. And then comes that chapter 3 of our origin story. Let me show that this paper came in 2017, as I have told you earlier, and this paper introduced transformer architecture, which is completely solved the sequential training problem of the previous architecture. So you can see this is transformer architecture, very high level. This architecture is also an encoder decoder architecture. Uh, this decoder architecture. This architecture is also an encoder decoder architecture. There is an encoder and there is an encoder here, decoder here, but that the only similarity, everything else inside has changed. First of all, the biggest change that this paper made uh, was that there was no LSTM or RNN components here. This entire architecture is based only and only on attention. That the two is a special form of attention. This is based on what we call self attention. Second, here you will see many different types of components that you have read earlier in this course, like residual connection or layer normalization or feed forward neural network. So this architecture was very different from all the old architectures of the first fall. And the best thing that you will see here is that the interplay of many different components was created, which created a very efficient architecture which you can train in parallel. And because of training in parallel, this architecture is highly scalable, which means you can actually use huge data sets to train the architecture. For example, the concept of transfer learning was introduced in NLP, and then models like BERT and GPT were trained, which you can fine tune very easily. That's why this transformer is a groundbreaking technology. So, if I tell you in my experience, what are the three best things in this paper, then first of all, LSTMs was ditched and self-attention was used, due to which the entire architecture can be trained parallel, which speeds up the training second, which speeds up the training. And that another one is this architecture was made very stable. I wanna mention here the hyperparameters used to create and train this architecture. Two hyperparameters are actually very stable and robust in the sense that there have many changes in the last 6 7 years in the transformer architecture, small and big best, but mostly the hyperparameters that we have used in this paper, the value that we have used, you can easily train your model even today by using same values. And the others are a little incremental. Incremental means that you take the previous research paper and make a small change in it. For example, look at the above example. This paper had an encoder decoder architecture where you were sending context where you were sending context vector. So you changed this architecture a little bit in in the next on that, instead of sending context vector directly. And the weirdest thing about this model or this paper, the values that were used, you can easily train your model even today by using the same values. And the weirdest thing about this paper is that generally research papers are a little incremental. Incremental means that you take the previous research paper and you make a small change in it. For example, look at the above example. This paper had an encoder and decoder network where you were sending context vectors. So you changed this architecture a little bit in the next one, that instead of sending construct vector directly from here, you send context vector at very decoder time, every decoder time. So this incremental small change, but attention is all you need. Very groundbreaking paper because it is not actually incremental. After reading this paper, you will feel like that time travel really exists. It seems like a time travel from the future came in 2017, and traveler came from the future uh, in 2017 and told these researchers to make such an architecture. this exists in the future. And these people created the architecture because when you read this, when you read this architecture, you will realize that it does not have much relation with the previous architecture. This architecture is completely different uh, from rest of the architectures. Like you should feel that everything feels random. Postal team was removed. Instead of that, a new thing called self-attention has came. Then connections are being used here and there, and then your forward network is talking to your self attention. Layer normalization has been used, cross attention has been used. Then so many small big different components which did not exist in the earlier architecture. This completely new architecture has been developed from scratch. But the best part is that this architecture actually works. Not only does it work, it has created a lot of uproar. So I will not go into uh, its details right now, because we will go into that in multiple videos that are going to be read in details. But just to give you an origin story, what were the factors of how transformers that pushed the creation of transformers, and I wanted to give you a rough idea of how this whole thing was executed exactly. I hope I was able to motivate you and a little sparked I sparked a little curiosity in you. Now the origin story just summarize the entire timeline. I will tell you one by one what happened uh, so from 2000 to 2014, the models that were dominating in NLP were mostly your RNN and more than that LSTMs. Okay, no, in 2014, then your encoder decoder architecture came, and along with that, your attention mechanism was introduced in 2017. Then the attention is all unit paper cam, and throughout that, finally transformers were introduced. If you talk about 2018, then this time when some more bigger transformers trained were like uh, create created like BERT, GPT, and in short, your transfer learning started in NLP. After that, uh, in the next 2 years, from 2018 to 2020, the concept of transformers was actually introduced in different domains. At this time, a lot of works was done on transformers, and many science and structural biology based models came out, such as DeepMind's AlphaFold 2. So this period after that, in 2021 onwards, generators started, where you start seeing many tools like GPT-3 or DALI or Codex. Okay, then if you talk from 2022 till now, then it's all chat GPTs, right? Mm. Apart from that, another very famous thing that you will hear about is stable diffusion, right? So if you talk from 2022 till now, then it's all chat GPTs. Apart from that, another very famous thing that you will hear about is stable diffusion, and mostly transformers related stuff. So this is a rough timeline how transformers came into existence and what have they done in the last 6 to 8 years. Okay, so you should have this overview, especially if you are interested and you are reading this whole thing. Let's discuss the main advantage of transformers. So the first and the most important advantage that we already know is scalability, because the architecture does not have the component of LSTM and is only attention based. You can train parallelly. Training is you can train parallelly. Training is fast, and you can train on large data that is highly scalable, because of which the second benefit comes, that is transfer learning. You can train transformers on very large data sets. You can train freely using unsupervised training, and then you can pick up the transformer and apply fine tuning on it, and you can use that transformers on your custom tasks, like directly without much effort. And third is multi-model input output. As I discussed a while ago, transformers is a highly flexible. If you are able to create the right representation, then you can use not only text but also different models like image and speech. With transformer you can create different types of applications. We talk about if you are, we will talk about it later. Very flexible architecture, which means you can create different types of transformers by changing multiple things. You can create encoder only transformers like bird. You can also create decoder only transformer like GPT. It really depends on the requirement of what kind of application you want to create, and make changes in architecture according to that. Next advantage is that ever since transformers has come, and there has been a lot of uproar in the entire community. Everyone's first preference is to learn as much as they can about transformers as soon as possible. And because of this overall curiosity, transformers is very active topic, which is discussion amongst the community members, due to which you will get a lot of library tools, etc. in the vibrant community around transformers. A lot, like you can see after the 2022. Uh, in the vibrant community around the transformers, a very good library called Hugging Face, using which you can quickly download and fine-tune transformers for transfer learning. Apart from this, you will also find a lot of videos and blogs, because a lot of people are reading about transformer. A lot of people are also creating content on it. So in today's data, if anyone wants to learn transformer, then you will get a lot of resources. It's not something which has a lot of resources. Okay, you will get plenty of good resources to learn about transformers. And the last benefit I would say is this: it can easily be integrated to other AI techniques. I can give you example like what can do you you can very easily create a very good quality image generator by adding transformers with GANs. Exactly, this works is done in Dali. So similar setup through transformer, you process the input you get, and then by applying GANs, using an architectures like GANs, you generate the output image. Similarly, you can create a very interesting gameplay by using transformers with reinforcement learning. Okay, so whatever strategy development is happening through reinforcement learning, and whatever understanding of that current state is being developed is being done through transformers. Similarly, you can create an application for image caption generator or visual search. Let me now let's discuss about the advantages. Okay, so the main advantage of transformers, the most important that we already know is scalability, because the architecture does not have the component of LSTM, and it's only uh, attention based. You can train parallelly. Training is very fast, and you can train on large data that is highly scalable, because of which the second benefit comes, that is transfer learning. You can train transformers on very large data sets. You can train freely using unsupervised training, and then you can pick up the transformer and apply fine tuning on it, and you can use that transformers on your custom tasks. Okay, so first and the most important thing is connectivity. Okay, so directly without much effort, third is so we have done two things, and the third part is multi-modal input and output. Okay, directly without much effort. Uh, Multi-modal input and output, as I discussed a while ago. Transformer is highly flexible. If you are able to create the right representation, then you can use not only text but also different models like image and speech. With transformers, you can create many different types of applications. If you talk about uh, uh, flexible architecture, which means you can create different types of transformers by changing multiple things. You can create encoder only transformers like BERT. You can create decoder only transformers like GPT. Really depends on the requirement of what kind of applications you want to create, and you can make changes in this architecture according to that. So next advantage is that ever since transformers has come, there has been a lot of uproar in the entire community. Everyone's first preference is to learn as much as they can about transformers as soon as possible. And because of this overall curiosity, transformer is a very active topic discussion amongst the community, uh, due to which you will get a lot of libraries, tools like tools and etc. In the vibrant community around transformers. A very good library called Hugging Face, using which you can quickly download and fine tune transformer for transfer learning. Apart from this, you will also find a lot of videos and blogs, right? Because a lot of people are reading about transformers, a lot of people are also creating content on it. So in today's date, if anyone wants to learn transformer, then you will get a lot of resources. It's not something which has a lot of resources, not have a lot of resources. Okay, you will get plenty of good resources to learn about transformers. And the last benefit I would say is it can easily be integrated to other AI techniques, right? So integrated with like example of GANs, transformers, image generators. uh, uh, what you can do, you can very easily create a very good quality image generator by adding transformers with GANs. Exactly, this work is done in Tally, right? Okay, a similar setup through transformer. You process the input you get, and then by applying GANs using an architecture like GAN, you generate the output image. Similarly, you can create very interesting gameplay by using transformer with reinforcement learning, where whatever strategy development is happening through reinforcement learning, and whatever understanding of the current state is being developed is being done through transformer. Similarly, you can create an application for image caption generator or visual search where you can integrate transformer with CNN. You must have also heard about vision transformer, like similar applications. So on the whole point that you can also create interesting applications by merging transformer with different techniques. So these are 5 6 advantages of transformers according to me, which you should know, and you will be good to go. So now let's discuss applications of transformers. I'm telling you the most famous transformer application. You must have heard about it. The first one is Chat GPT, right? Applications of first one is Chat GPT. Yes, here it is. The applications. And the functionalities of ChatGPT: look, summarize meetings, find new insights, increase productivity, generate and debug code, automative repetitive tasks. Uh, these all the huge features. Explore more features, right? There are a lot of things which have been updated. So the first one is ChatGPT, right? So there is no need for introduction for the last one, and 1.5 year most highlight on every news channel, every website. You must have been hearing the name of one software, that is ChatGPT. So what is ChatGPT? ChatGPT is basically a chatbot built on top of GPT-3. GPT-3 is a transformer generative pre-trained transformer created by OpenAI, of course. So what does ChatGPT do? You give it a text input, and it generates text for you in return. So for your purpose, if you want, you can get a poem written by it, or get it to code or any other work. ChatGPT can do it for you easily. The second most famous example would be DALI. So DALI is a software by OpenAI, again implementing transformer. DALI 2, basically what it does is, that if you implementing transformer like DALI 2, what it does, that if you provide it a text, or if you provide a prompt, then using that prompt it generate images. So you can use DALI to generate any kind of image. You can go to the website, or you see example like this. You see example like this. In this example, when you give in the input an astronaut riding 3 horse in photorealistic style, this is the output, and the best part, you get multiple outputs, right? See here, get the output like this, and you will also get multiple outputting, inputting variations, this kind of multiple options. So you can select one of them. So yeah, this is the second one. Third one is little less, but probably according to me more powerful in impact, is AlphaFold. AlphaFold 2 precisely. Let me show you. Here it is. AlphaFold. This is the third example. It uses transformers behind the scene. What is AlphaFold? AlphaFold is, this is a project of Google DeepMind, where you actually do research uh, in structural biology, and the main idea behind AlphaFold is to find out protein structure. Okay, in space, how the protein structure, uh, like recently it came in the news that the structure of many proteins that exist in nature was decoded, and this was a very big scientific breakthrough. So I would recommend that you go and read about it once. The fourth, and the fourth, also interesting application is OpenAI Codex. Okay, OpenAI Codex. Codex is basically a tool that converts natural language into code. So you might have seen GitHub's Copilot. What's happened is that as soon as you go to type the code, it gives you recommendations and generates the code. So GitHub's Copilot is actually based on OpenAI Codex. Okay, so this is like, for me, the fourth most popular one, and apart from this, many more applications have came out today, which is based on transformer architecture. If you want detailed information at a single place, then I would recommend you going to this paper, uh, a comprehensive survey on applications of transformers for deep learning tasks. This paper uh, will give you a detailed information, but almost everything is covered in a single paper. uh, Whatever transformer architecture is available, whatever transformer application is available under different categories. So I recommend you to go to the paper also. Let's talk about disadvantages. Okay, so what are the disadvantages? So these are few disadvantages of transformers. So it requires high computational resources. Okay, you can train transformers in parallel, like process information parallel in encoder, but to train it, you need GPUs so that you can do that parallel computation. We all know that GPU is costly, so high computation cost is involved in training transformers. This is first drawback. Second one is data. Just like every other deep learning architecture, transformer also has this limitation that to be trained properly, it requires data to work properly. But good part is mostly whatever applications are made or are being used till now, like large language models. These are very easily trained on text data and can be trained in text data also with the help of unsupervised pre-training. Basically, you don't need labels. But let's say if you are working on a problem of very specific domain, and you have to implement transformer there, then you will need a lot of data, okay, to make sure that your transformers is trained properly, because it's all about data, but not any data. So just like any other model, here also there is a risk of overfitting, since there are a lot of parameters involved. If there is no variety in the data, then the chance of overfitting is very strong here as well. Next one, which I would say is energy consumption. Since these are like huge models, to train the models you like, you need very solid hardware to run solid hardware. You need electricity, and electricity, it comes at the cost of something so many. So my environmental concerns is that the big models, large language models, to run them, to train them, you need a lot of electricity consumption, and there are many environmental hazards around it, which are talked about a lot these days. Next, I would say the next one, the next disadvantage is interoperability. Even though the results that came out of the transformers are very surprising, the surprise us, they surprise us, but nobody honestly knows what exactly going on inside the transformer, because it is mostly a black box model, and interpretation of the result is difficult. So if you implement the transformer in same way in some very crucial sectors like banking sector or health sector, then there can be a problem there, because even though the results are coming correct, it becomes important it becomes important to explain why the results are coming like that. Even those transformers are not able to do it. The last problem is bias. Again, just like any other models, if there is a bias in your data, then the problems starts appearing in the results of the model. Also, there are ethical concerns, because till now we have seen that to train the transformer, basically the model has been trained by by taking data from the entire internet. So now there are also ethical concerns, that are so many lawsuits ongoing on companies that they have used the data of some other companies, uh, and other websites without asking and without permission. So one has to be very careful about these all things. So these are some of the major disadvantages which is stopping the transformer at the present. But sure, future is bright. Researchers are continuously working on fixing all these problems. In the fully future, we will see more powerful transformers. So let's talk about the future. Whatever has happened till now is very good. Transformers has probably become the number one neural network architecture, at least as of today. But what about the future? Let's discuss once uh, what will happen in the future. So first of all, one thing which a lot of work is already being done is to improve the efficiency. Let's Yes, these are the few points. First of all, one thing, a lot of work is already being done is to improve the efficiency of transformers, right? In terms of training and models, so a lot of work is going on here. Here, work is like uh, proning quantization. There's one more technique called knowledge distillation. With the help of all these efforts are being made to reduce the size of the model, but its performance should remain as good as possible. Okay, after this, another thing, one which a lot of work is being done, focus is being done, is to improve the multi-model capabilities of transformers. Till this point, text was the most prominent point mode, but now a lot of work has started happening on images and speech as well. Apart from this, if you talk a lot, if you talk, a lot of work is going on. Sensory data transformers is also being prepared for biometric feedback. Okay, so in which your fingerprint sensors, right, or retina scans, such input transformers should also work for time series based data. A lot of work is going on this as well. So in future, you might see applications that will be able to handle many of these types of modality very easily. If you can handle multiple modalities together, then very exciting applications will also come out of it. Okay, so the third point is responsible development. Transformers means completely eliminating bias and overcoming any ethical concerns. Also, something on which a lot of focus will be given in the future. Another interesting thing that can happen in the future is that you will have domain specific transformers that will be trained on domain specific data, which we have talked earlier. So in the future, it is possible that along with ChatGPT, there will be a doctor GPT, a legal GPT, a teacher GPT, and all of them will be experts. So in my domain, uh, if I ever need to take any legal advice, then actually I don't go to ChatGPT. I will go to legal ChatGPT because it is such a specialized transformer that is trained on only on legal documents. So I see this also a very exciting future. One more thing is that transformers go multilingual. Till now, most of the training that has been happened, most of the data on the internet is around English. But recently, I can see development around regional languages based transformers, like many on Hindi also. Right now, Indian startups are working on it. Recently, the founder of Ola has started a company called uh, AI. I guess the company is also training transformers from scratch in Hindi. So, if transformers are trained in different languages, then something very exciting can came out of that also. And last, in interoperability, as I said, till now whatever result comes out of these transformers, where do not know why it came, like that, because essentially it is a black box, but surely a lot of research will be done in the domain now, that by opening the transformers, effort will be made to understand why it gave the result which is gave, right? A lot of effort will be made to make it white box, like to know there is the reason of why the answer is such like that. So, and the benefit of doing that will be that many critical domains like banking and medical, such domains where why the decisions was made is very important, they will start getting concerned, and then transformers will enter these fields. So again, it would be a great application around well also. So this is, in my opinion, this is going to be the future in the next five years, maybe less, because development is happening in the space. Okay, you can never say what will come out, but this is how future should look. So that's the video, guys. I really hope I was able to impart some knowledge which will help you. I will also share with you the future plan. The future plan is 3 to 4 videos. Will be understand the architecture of the transformer in detail, and it will probably be the most important video in this whole series, because in the next video we are going to cover topic called self attention, uh, like center transformer. We will cover the most important mechanism behind the working of transformer in depth in the next video. Meanwhile, if you like the video, please like it, and as earlier I have said, I need support and the approval from Nitish sir. So let's see what will happen. I'm excited to work further. So maybe in future you will see my playlist, or maybe not. It totally depends when Nitish sir uh, feedback. Okay. Thank you so much for watching. See you further. Stay tuned.